Okay, so in the previous video, I asked you to differentiate y equals x cubed from first principles and hence find the gradient of y equals x cubed at x equals 0, -1, and +1. So what did you get? Let's work through it. So remember now, y equals x cubed is our function here. If you choose a point, any point, x equals that, just like with the previous one with x squared, you choose another point. This is x2, but x2 is given by x plus some value h. So here you have x plus h, all right? And whatever that is, when you have x here, what you have here is x cubed. And when you have, so when you have x, y is x cubed. When you have x plus h, when x is x plus h, y would be, right here would be x plus h cubed. Now, the gradient of a line that is drawn through x cubed and x plus h cubed, that is, if you consider this P2 and this P1, this is one point, this is the other point. When a line is drawn through these 2 points, the gradient, of course, is y2 minus y1 over x2 minus x1. So we can choose these 2 points and find the gradient of a line drawn through it, and then make h get smaller and smaller, approaching 0. So we end up at x and we find the exact gradient at x. So that's the idea behind it. So let's go. y2 would be x plus h cubed. So y2 is x plus h all cubed. We want, alright, let's do it this way. We want to find x1, y1, x2, y2, and the gradient is y2 minus y1 over x2 minus x1. Now, here, x1 is x. So, x1 is just x. What is y1? When you have x1 as x, y1 is x cubed. So, y1 is x cubed. What is x2? x2 is x plus h. So, x2 is x plus h. And then, y2 is x plus h cubed. So, y2 is x plus h cubed. Now, the gradient is equal to y2, which is x plus h cubed, minus y1, which is x cubed, over x2, which is x plus h, minus x1, and x1 is x, alright? So what you have is x plus h cubed, which is x plus h, times x plus h, times x plus h, minus x cubed, all divided by x plus h minus x, x plus h minus x. Alright, let us partition the board and continue working over here. So what we have here is x plus h times x plus h. Let us multiply the 2 of the x plus h together first. X plus h times x plus h. X, we have x times x is x squared. So we have x squared plus x times h is hx. hx plus h times x is hx again, hx plus h times h is h squared, and that will multiply x plus h, and all of that will minus x cubed over x minus x is 0, so it's over h. Alright, here now, hx plus hx is 2hx, so let's just put that as 2hx. We don't have a lot of space, so let's just do that. 2hx. Alright, we multiply again. X squared times x would be x cubed. So we have x cubed plus x squared times h, which is hx squared, plus this one now, 2hx times x would be 2hx by x, which is x squared, plus 2hx times h, which is 2 times h squared times x, 2h squared x, plus this one now. So we have this time this, this time this, then this times, we have x squared times x with 8, which is x cubed, then x squared times h, which is hx squared, plus 2hx times x, which is 2hx squared, plus 2hx times h, which is 2h squared x, good, plus h squared times x, which is h squared x, plus h squared times h, which is h cubed minus x cubed all over h. Alright, let me redo that h. Rewrite that h. Alright, what's going on up top here? We have x cubed, hx squared. Is there any more x squared? We have 1hx squared plus 2hx squared, which is 3hx squared. We have a 2h squared x plus another h squared x, so that gives us 3h squared x. Then we have plus h cubed plus h cubed minus x cubed all over h, right? Notice here, this x cubed and this x cubed, we could put them side by side and get x cubed minus x cubed. So the x cubed is gone. What we have up top here is 3hx squared plus 3h squared x plus h cubed over h. We could factorize, If we have h outside a bracket, we would have 3x squared plus 3hx plus h inside, h squared inside the bracket over h, and this h would cancel this h. So what do we have here? Is 3x squared plus 3hx plus h squared. Alright. Now what happens to this? As h approaches 0, what we would have is 3x squared plus 3 times 0 times x, which is 0, plus 0 squared is 0. So we would have 3x squared. Okay, good. I hope that's what you got. So it is 3x squared. So dy by dx is 3x squared. That is when y is equal to x cubed. Alright? So, having differentiated x cubed from first principle, we can now find the gradient of the curve at certain points. So let's go ahead and do that. Let's erase some of these things that we had before. Now, when x equals 0, that's right here, when x equals 0, we have dy by dx is equal to 3 by 0 squared, which is 0. Alright, so what that is saying, the gradient is 0, means that what you would have is just a horizontal line, very flat, passing through that, so the gradient is 0. If you should try to draw the tangent, although this would cut through part of the curve, any line that passes through 0 would be a horizontal line. The gradient is 0. Alright, let us look at what happens when x equals negative 1. When x equals negative 1, dy by dx is equal to 3 times negative 1 squared. Negative 1 squared is 1, so it's 3 by 1, it is 3. So when x is negative 1, it will be at this point. The gradient of the curve is 3. So if we draw the tangent at that point, right, what we would have is a line which has a gradient of 3. Alright, let's find out what the gradient is when x is 1. Right, when x is 1, what happens at x is equal 1? At x equals 1, dy by dx, the rate at which y is changing with respect to x, will be 3 times 1 squared, which is just 3. So the same thing happens here. The gradient would also be 1 at that point. Alright? So here we find the gradient at negative 1 and 1 being equal to 3. Alright? Now, here what we did was to find that when you had y equals x squared, dy by dx was 2x, and we found that when y was equal to x cubed, dy cubed, dy by dx was 3x squared. We're going to talk some more about that in a different video. Alright, so let me just clean the board in preparation for the next video. Clean parts of the board in preparation for that, and then we'll talk a bit about differentiating x raised to a power. So I'll see you then.